Lesson 4-1, Classifying Triangles. How do the parts of triangles help us classify them, and how is this information related to other things we have learned? In geometry, a triangle is a figure named when three non-collinear points are connected by segments. So here are my three non-collinear points, and if I connect those segments, I now have a triangle. Each pair of segments forms an angle of the triangle. So I have segments DE and FE, I have segments EF and DF, I have segments FD and DE. The vertex of each angle is a vertex of the triangle. So how is that useful? Triangles are named by the letters at their vertices. So triangle DEF is written as a triangle symbol DEF is shown below. The sides of this triangle are EF, FD, and DE. Please notice that they are all segments and have the segment symbol on top. I also have vertices or vertex. Vertex is one, vertices are plural. The vertices are just the points that are connected, so I would have points D, E, and F. I also have the angles, which are made up of the segments, and I have angle DEF or angle E, angle EFD or angle F, and angle FDE or angle D. In a previous chapter, you classified angles as acute, obtuse, or right. Triangles can also be classified by their angles. All triangles will have at least two acute angles. The third angle is either acute, obtuse, or right. Here are four classifications for triangles by their angles only. An acute triangle has three acute angles. An equiangular triangle, equi meaning equal, angular meaning angles. An equiangular triangle has three congruent acute angles. An obtuse triangle has one obtuse angle, and a right triangle has one right angle. Triangles are usually named by their largest angle. That is something you should probably write down, that triangles are named by their largest angle. We want to classify the triangle as acute, equiangular, or obtuse, or right. Well, if I look at the angles, all the angles are equal to 60 degrees, and they are equal, therefore it will be equiangular. If I look at this triangle and I classify by the angles only, I see that the largest angle is 130 degrees, which is obtuse, and therefore this is an obtuse triangle. Here is an example for you to try. Here is another example. Here is another example. Triangles can also be named by their sides. An equilateral triangle has three congruent sides. An isosceles triangle has at least two congruent sides. Please note that this does not say that it has exactly two congruent sides. Equilateral triangles have two congruent sides, so a lot of the information that we learn about isosceles triangles will be applied to equilateral triangles as well. A scalene triangle has no congruent sides. Here is an example to name the types of triangles by their sides. It says the frame of this window design is made up of many triangles. Classify triangle ABC. So triangle ABC is right here. It appears as though AC is congruent to CB, and therefore it will be isosceles. Here's an example for you to try. Here is another example. Now we can see that this example uses things that we have already learned. For example, it says that C is the midpoint. That means that BC is half of BD, which means that this will be 1.7. Well, 1.7 for segment BC is not equal to 1.2, but since this has a tick mark and this has a tick mark, I know that at least two sides are congruent. Since this is 1.7, it is not equilateral, it is isosceles. Here is an isosceles triangle. The angle formed by the congruent sides of an isosceles triangle is called the vertex angle. The side opposite the vertex angle is called the base. The base is also the side that is not congruent. The congruent sides are called legs. The base is the side, therefore, that is not congruent. And the two angles formed by the base and one of the congruent sides are called the base angles. This is for an isosceles triangle. I can do algebra using these relationships. It says find the measure of the sides of isosceles triangle KLM with base KL. Because it says base KL, we know that KL is not congruent to LM or KM. Since this is isosceles, I know that two sides are congruent. So I can write it so that KM is equal to ML, or 4D minus 13 is equal to 12 minus D. I can then solve the equation by adding D to each side, and then I will add 13 to each side. I get 5D is equal to 25, and therefore D is equal to 5. But it wants me to find base KL. So I'm going to take this D is equal to 5, then I substitute into KL, D plus 6, or 5 plus 6 is 11. So the question initially asks just to find KL, but you can also find KM and ML as well. Here is an example to try on your own. Please note that it says it is an equilateral triangle. You only need to use two of the pieces of information at once. You will not be solving with all three sides at once. This concludes Lesson 4-1, Classifying Triangles. Please make sure to bring any questions or concerns you may have to class.